Hi, friends. Welcome back to our series of sessions. Today, we're starting a new series on advanced manufacturing. So, this particular session is mainly on transforming manufacturing, the future of work and workforce. Let's understand the industry's imperatives for academia, thereby bridging the talent gap. We all know that the success of a nation's manufacturing sector hinges significantly on its ability to cultivate a skilled, adaptive, and industry ready workforce. As industrial landscapes rapidly evolve, so too do the expectations placed upon academic institutions to align their educational outputs with real world industry needs. Now, this particular session delves into the critical objectives that industry seeks to realize through its collaboration with academia and examines the persistent challenges that educational institutions must actively address to effectively bridge the talent gap in modern manufacturing. That's where the technology convergence comes. We have IT, information technology, we have operational technology, we have communication technology, we have graphics technology, and we have emotional technology or engineering technology. And if you see all these things, the past has been the siloed technologies like nuclear families. Today we have the technologies are like a combined family integrated with IPv6 massive address space for connectivity, protocols and APIs which will enable system interoperability, giving life to things, both living and non-living. And thereby we have an instantaneous communication enabled by high internet bandwidth. So if you see the unimaginable new capabilities with technology convergence, we have digital workforce, omnipresence, autonomous operations, resulting in remote monitoring and controlling. We have augmented intelligence for better decision making, predictable future and automatic recommendations, real-time and contextual communication and collaboration, resulting in immersive experiences. Thereby, we have extended business ecosystem with partners and suppliers on one line. So for this, we need to unlock the power of technology convergence. Let's see a few examples. We have the most popularly known as dark manufacturing, which is called as lights out automation, which operates in complete darkness, fully automated systems capable of running without human intervention, even in 24 into 7 operations. Autonomous quality control, inline sensors, and AI systems continuously monitor and correct details in real time. Then we have minimal human presence, safe, secure, and remote control processes with very few on-site workers. We have predictive maintenance, which are IoT enabled. Equipment predicts and prevents failures before they occur. Integrated digital twin simulation is another one, which with virtual replicas of the factory, enabling real-time optimization and scenario testing. So digital twin for chiller is another example where we have for real chiller, we have sensors, pressure, temperature, and flow rates, and the test the new chiller control algorithm with higher uptime and energy savings. And we can predict maintenance needs, adjust load balancing, simulate control strategy changes for the digital twin. Higher uptime, energy savings, and safer operation are the advantages that we have. And then we have collaborative robotics. We have the thing. Collaborative robotics, which we normally call them as cobotics. Collaborative robots. Then predictive maintenance with service based on predictions of car condition. And then preventive maintenance, we have service at regular intervals of time or mileage. So we have flexible micro factory cells with leading to all these things. Example is Porsche's 3D printed custom seats, which are there, the thing. And then digital thread, how data flows from design through recycling. If you see the life cycle stage and software tools, initial CAD design of the battery, example software or Softworks, Cassia, Siemens NX, For a life cycle stage of supplier sourced cells and components, we have Siemens Team Center, PTC Windchill, SAP, Oracle. Then for assembly on the factory floor, we have Siemens Op Center, Rockwell Factory Talk. For quality testing results, we have Siemens Op Center Quality, SAP QM. Real-time sensor data while the vehicle is drawn driven use the software on AWS IoT, PTC ThingWorks, Azure IoT. For maintenance history at service centers, we have ServiceMax, Salesforce Field Service, SAP, HANA, etc. And then for battery recycling at end of life, we have Dassault Enovia, SAP EHS, Oracle SCM. So this is an example for lighting. We have messages and illumination. For user data, we have false and fatigues. For sensing temperature, motion, location is GPS and RFID. Communication can be cloud access and alerts. And the soul, we have kinetic charger. This is a IoT operated diaper. For high time to change the diaper, the signal can be conveniently sent wherever possible. Then we have temperature regulation. This is another application where wake up technology allows you to wake up with the temperature and gentle vibration at chest level. And each side of the pod can be set separately to anywhere between 55 degrees to 110 degree Fahrenheit. 8 sleep app monitors your key health metrics while you sleep. And then the pressure point for manufacturing industry due to technologies convergence, which we have all seen, is for digital age customers' needs and wants in terms of digital dragons. So we have what is called as GAFAM. And for physical and digital worlds convergence, we have traditional manufacturing industries which are sandwiched together, resulting in how to compete with the digital dragons, lizards, digital age manufacturing. And then volatility, uncertainty, complexity, and ambiguity, which are basically the VUCA world, we call it. So digital lizards like tech startups. And for this to tackle, we need to how to create new business opportunities and improving business performance in the digital era. So the digital dragons are nothing but Google, Amazon, Facebook, Apple, and these kind of platforms, whom we normally call them as. So we need to understand how to stay relevant in fourth and fifth industrial revolution and how to compete with the digital dragons or lizards in the digital age. Then welcome, we have the fifth industrial revolution on the onset. The fifth industrial revolution is nothing but humanity-centered solutions, compassionate capitalism, innovation with a purpose, bio-inspired design, sustainable development, augmented human intelligence, teamwork by humans and machines, Internet of bodies and behavior, immersive virtual worlds, and nearly autonomous execution. We cannot use stones to produce fire when there are matchboxes and lighters available. Realizing organizations to meet the needs of fifth industrial revolution is most essential. So we need new roles, new behaviors to align and work in the fifth industrial revolution. Now let's see, why are new roles required? So traditional roles are becoming obsolete. Automation is replacing repetitive and routine jobs. Advanced technologies need new skills, digital twins, cobots, and 3D printing demand data and systems expertise. Innovation needs specialists. Personalization and customization call for new engineering and digital roles. Human-machine collaboration where roles must evolve to co-create with and supervise intelligent systems. So we need adaptability to change, growth mindset, and resilience are essential in a VUCA world. Cross-disciplinary collaboration, breaking silos, and working across domains is critical. Customer and humanity-centered thinking, where balancing profit with sustainability and social values. Digital confidence and curiosity, where comfort with immersive, autonomous, data-rich environments. Teaming with intelligent machines, where working alongside AI and robotics with human judgment and creativity. So workforce transformation, the evolving roles are basically jobs to be eliminated or significantly reduced or repetitive and manual, assembly line workers, material handlers, routine quality control where automated systems reduce manual inspection, basic data entry where automation of data flow across digital thread reduces manual input, clerks recording production numbers or inventory levels, workers manually logging maintenance history. All these will be transformed. So the new roles required today in manufacturing organizations are predictive modeling digital engineer, additive manufacturing R&D engineer, IIoT architects, IIoT platform specialist, industrial data scientists, digital twin engineer, predictive supply network analyst, smart factory manager, robot teaming coordinator, smart safety supervisor, smart QA manager, smart production scheduler, 3D printing engineer, sensor technology specialist, and sustainability engineer. These are all the new roles required in the manufacturing organizations. So all this can happen with the agentic AI. If you take the supply chain example, the typical characteristics of an AI agent is in terms of perception, processing and interpreting various types of input data, recognizing patterns and relevant information from the environment, reasoning being analyzing information and making logical inferences, evaluating options and forming conclusions based on available data. And then metacognition here is understanding its own capabilities and limitations, monitoring and evaluating its own cognitive processes, self awareness of knowledge boundaries and confidence levels. Then you need planning, prioritizing tasks and allocating resources based on context and goals, anticipating potential challenges, and developing contingency plans. So, like this, we have autonomous execution, learning and reflection, iteration and adoption. Basically, autonomous execution in terms of independently taking actions without constant human oversight. Whereas learning and reflection is in acquiring new knowledge from experiences and outcomes, then analyzing the successes. Continuously improving performance through applied learning, adjust strategies based on feedback and new insights, thereby evolving capabilities over time through systematic enhancement. So if you see the real-time example, we have agent for smart inventory management, global retail chain. The scenario is a global retail chain, can be Walmart or Amazon, deploying AI agents to autonomously manage inventory across stores and warehouses, ensuring the right products are always in stock without overloading storage. So AI agent characteristics can be in terms of perception. AI agent ingests data from RFID readers, barcode scanners, and smart shelves, warehouses and stores, POS systems, and CCTV. Reasoning is evaluates which items are moving fast, what's in storage supply, and then which location has access stock. Metacognition is recognizing uncertainty, flags for human review is confidence is low, and then learns where forecasts go wrong and improves failure decisions. And then we have planning, creates a real-time stock reallocation plan, autonomous execution in terms of places restock orders without human intervention. Then learning and reflection is in terms of missed deliveries, overstock situations, past sales trends, which updates reorder rules and planning heuristics. So finally, we have iteration and adoption, which continuously refines strategies based on weather AI APIs, preparing for a storm-driven spike in bottled water sales, customer returns and satisfaction signals from e-commerce platforms. So AI role transition map in supply chain management. We have a demand planner. AI agent support is in terms of demand prediction agent, inventory optimization, and the transformed roles with new skills is AI augmented demand strategist who interprets AI forecasts, plans scenarios, and manages demand stocks. So procurement manager should be as AI agent support will be in terms of supplier, evaluation agent, automated negotiation agent, procurement approval agent. Strategic supplier relations manager focuses on long-term partnerships, ethics, and resilience. Logistics coordinator can be smart routing agent, fleet optimization agent, real-time shipment tracking agent, etc. Where the transformer role can be AI logistics analyst, supervises AI agents, resolves exceptions, enhances route intelligence. Then the warehouse supervisor, AI agent support will come in terms of warehouse, robot coordination agent, AI driven order fulfillment, defective goods inspection agent. Whereas the transformer role can be an AI integrated operations leader, ensuring harmony between human and robot flow workflows. Then risk and compliance officer, the AI agent support will be in supply chain risk assessment agent, fraud detection agent, regulatory compliance agent. Transformer role can be proactive risk architect, defines new risk models, ethical frameworks, and governance for AI systems. So sustainability and procurement officer will have support from AI in terms of fleet optimization agent, sustainable procurement tracking agents, etc. The transformer role could be ESG and AI ethics champion. So maintenance and quality control manager will have product maintenance prediction agent, IoT sensor-based monitoring agent, blockchain-based warranty and maintenance agent. So the transformer role can be new skills in predictive maintenance strategies. And then customer support specialist, AI chatbot for order queries, returns and refund automation agent, where human experience curator is the transformer role, which handles complex automation systems, customer emotions, and trains artificial intelligence on empathy. So that's all about we have, and have a nice time. Thank you very much.